So you guys are going to work next. I'm looking for average rate of change over some intervals for coffee shops. Looking at the graph, what do you notice about the number of coffee shops around? It looks exponential, right? It's increasing more and more. Right now, let's say you go to any even mid-major city. Grand Rapids would be a mid-major. Or you go to Chicago. I noticed big time last. Do you notice in Chicago, like every block has a Starbucks?
Oh, absolutely.
Yes.
Like no problem finding a cup of Joe.
Like I was walking around.
Right?
Just gonna
So what you're going to do is this. You're going to use your information here to answer these questions. Now, on your sheet, they're on one slide, so it'll look nice. I'll probably leave it on this slide for now, okay? You're going to look at the intervals from 87 to 90, 87 to 93, and 87 to 97. The average rate of change for each interval. So then what you're going to do is you're going to make some observations about how well you think that average rate of change fits your data. Is it a good measure? Is it a bad measure? Is it close? Is it far? All right, and then you're going to use, the graph will be helpful for that. For number 3, you're going to actually draw on the graph. That's how you'll want to do it. Again, all of yours will be on one page. So in a moment, when we go talk about these after you've got some work, we'll probably hang out on this page, so I'll need your help with the questions, okay? So find the average rate of change for these intervals, and we're going to discuss, are they good? Is it good numbers to use? So we're going to look at some different intervals here. The first interval you were asked to find was 87 through 90. So just a visual thing I like to do sometimes, I like draw a little thing in like that. So I know I'm looking for 87 to 90, and I'm looking for the average rate of change. And so to find how the number of stores changed, I'm going to do 84 minus 17. Everybody good with that? And that's over how many years? 3 years. So 84 minus 17 is 67 stores. On average over those 3 years means 22 and 1/3.
Wait, no, that would be 20.
I got 22 and 1/3.
I got 22 and 1/3.
Oh wait, no, that's 70.
And that's going to be stores per year. Okay, so some things I'm hearing out there. It shouldn't be negative because I went from 17 to 84, which on average, I'm increasing. So it has to be positive if you got a negative because it went up, right, on average. And then what I'm going to look at here is looking at the differences. So 17 to 33, it's like 26. No, not 26, sorry. 16. Then here, like 22. And then here, like almost 30. Does 22 and 1/3 seem like a good number for those? Yeah, it's pretty good. So that's like question C that you had. I'm going to say pretty good.
Except when you get up to like 1996.
Well, this was only asking for this interval, right? So for this interval, 22 and 1/3 works pretty well. Oh, I shouldn't write pretty good.
What was that?
Pretty well. Works pretty well. All right, next up, it was 1987 till 93. So a larger interval. Let's see how it changed. 272 minus 17. Over an interval of how many years? 1, 2, 3, 4, 5, 6 years. So on average per year, 42 and a half stores. Stores per year. Now, that's more. So what's interesting is I still have the same years 3 years in, but my average is significantly more. 42 and a half. Are you seeing jumps of 42 and a half in here?
No.
Maybe this is close and this is close. Right in there is kind of close. So it's like okay. Yeah, let's say it's okie dokie.
It's mid.
Yep. So I just want to compartmentalize here. A short interval of time was pretty good. A little longer, it's okay. What do you guys think about even longer?
That's not gonna work very well.
Yeah, I think the technical term might be dog water, but let's see if it checks out. Okay? So, 1412 minus the 17. And how many years is that over then? 10 years? So 1412 minus 17.
1,395.
Divide that by 10 years, 139 and a half per year.
That doesn't look very right.
Well, it is right. That's on average, right? So that's a big average. Is that jump like indicative of our year to year very often?
No, I wouldn't say so.
It's probably like the closest tickets is
Like right in here, maybe?
not even though, because 272 to actually yeah, you're right.
Right in there, but like this jump right here of 16, not even close. This jump of right here, like 400. Yeah. So let's look at why this is true. So the big idea that we just found is the average rate of change was good for the short interval. Everybody follow that? Okay. So check out this short interval. Here's our first interval. What do you notice about that line in the dots? Okay, let's look at the second interval. We went, how many years on that second one? 6 years? Uh-oh, it doesn't want to work for me. Nope. It's because it's too close to the other one. Let me try to use my finger and see if that'll be... Oh, there we go. Okay, what about that one? Yeah, they're do you see that curve below it, but this like still not crazy far? Let's look at the last interval.
No.
I think it looks great. It looks like a bow.
Yeah.
Yeah, it looks like a bow.
So none of these are very close. And that's going to be indicative of a lot of exponential functions. Because we already found out the further you go out, you either approach infinity or you approach zero. So you're either decaying really quick and then flattening out, or you're increasing pretty slow and then all of a sudden really crazy, right? So this short interval works pretty well. This long interval does not work well. That's a big idea from today. We can still... Is the long interval's average rate of change bad math?
No.
No, it's a legit number. But is it a great description of our situation, of what's happening?
Yes, if you want to go in there.
No, like let's say you're the coffee company and you're the boss and you're like telling people how good it is, invest in my company. And then would you be more likely to say like, since we started 10 years ago, on average, we've increased 139.5 a year? Or would you be more likely to say, over the last 3 years, we increased by blah, blah, blah? Yeah. Is either one of those inaccurate math?
No.
No, but you can paint a different picture depending on different things, right?
It's a little bit like the bank account.
But there's really a number. I just don't feel like finding it because we got more stuff to do. Like, I want to find it, but Emmett. So we're going to look at a decay function here. We're going to revisit our solar cells. One thing I wanted to show is that last one. Let's go back to the graph real quick. That last one, if I wanted to draw a nice straight line,
We have another year this time. It's like 1990.
if I had a nice straight line, do you guys see like this chunk down there would be the easiest place to make it in general? Or maybe something like this, right? It's almost like there's different parts. And this is exponential growth. So tight and close to small numbers worked great. Small intervals worked great in general. So what I like to think about before you even get after this one is what area of this graph would be the easiest to make a straight line hit the most points?
The bottom?
Yeah, down here somewhere, right? Because it's flattening out. So just keep that in mind. Also, the further you go, the more off you get, right? A short interval, you can hit a lot of points. Even up here, a short interval, you can be pretty close. So keep that big idea as you approach this. You're going to look at Claire. Claire looked at the first 5 years and then the second 5 years, and she compared those chunks. You're going to confirm or deny her $12 and $2 a year decline for solar prices. And then you're going to look at extending that trend to see what happens with your partner in your notes. Let's go. Eyes up here, mouths closed. Okay, let's check out Claire. Claire's looking at the first 5 years first. And I like to just go right to my graph and write my ordered pairs. I like 519 there. Okay, so if it went from 80 to 19, this will tell me how the price changed for the solar panels, and that was over 5 minus 0. You don't have to do the minus 0, but that just shows the over 5 years, okay? So over 5 years, it fell by about negative $12.2. So Claire said, fell by about 12. Was she right?
Yes.
Check. Okay. Then she said the second 5 years. So we're going to go from 1, 2, 3. Do you think it wants us to start at 519 or 614? I did 614 last time, but this time I just read it and I was like,
No,
I don't
this
know.
is 1983.
Yeah.
Yes, we're 1983.
Oh, okay, there we go. 614 to 11.3. Okay, so how much did that change by? 11 over how many years? 5 years. There's my second 5 years, okay? So 3 minus 14 divided by 5, about negative 2.2. Claire said that it decreased by $2 a year. Now, that's a pretty big difference, right? Same function. Check out these lines. So over 5 years, that was a very good one. That line and that line. Which one fits better? I'm just drawing it. Which one fits better, the first 5 or second 5? The second, but is the first 5 that bad? No. A smaller interval would be closer. But these are pretty big changes. Now, this doesn't say to do it in there, but let's do 0 to 10 years, okay? So that'd be 3 minus 80 over 10. So negative 77 over 10. On average, how much is that per year? Negative 7.7. Is this very good for the whole situation? Not great. It's between the two, but really, the segments did a good job. Those intervals did a good job of saying what's happening in context. What do you think? The next chunk of time, will it be less than 2?
Yes.
Yeah, it will be less than 2. But will it be as big of a jump from that 12 to 2?
No.
No.
It'll be like.
I'm just going to say smaller jump down. It's going to be less and less because what's happening over here? How could you explain? It's flattening out, approaching 0, right? Yeah, do you have a question for me? Okay, cool. All right, y'all. Average rate of change. How does y change over x? Lesson summary, then I'll hand you the homework when you show me.